Today, I'll be we'll be discussing rather on tablet granulation. Right? We already talked in our last class how the tablet is being prepared, and granulation is one important aspects for tablet formulation, tablet preparation. We'll have some PowerPoint presentation also on this regard, and some discussion on this. Very importantly, I have also highlighted the text portion from the textbook which we are going to focus on, and few PPTs I have already uploaded. You can always check for that. So first, directly I'm coming into PPT before we are going for further discussion. I think I'll share my screen so that you can see it. I think my screen is visible to you. So basically, we are talking about tablet granulation technique and what are the things and process we are involving in a pharmaceutical industry, the process, how is it going to occur out. So basically, first one is, for example, tablet preparation means more than one ingredients are there, not only single ingredients, but we can have more than one. So if I'm having more than one ingredients in these situations, we must have the different unit operations should be involved. So I am having more than one ingredient which should be dried. All the ingredients should be dried. They should be milling. Milling, you know, right? Making into smaller particle, breaking the larger particle. So there can be different milling machines can be there. And one of the process is size reduction, essential. So all the ingredients for pharmaceutical preparation, as you know, any tablets will have more than one ingredient. One is active ingredients, another is diluents. Diluents can have binder, adhesive, lubricating agents, many varieties are there because they have some purpose. So all the ingredients are first blended. I mean to say, make a homogeneous powder. All of them are powder only, but we want to mix them together. So if I take some portion, all the ingredients in the same proportion should be there. So to make it proper mixing, the particle size, the shape of those compound, whatever we are using, they should be very similar. We cannot mix something which is one is a different property, different surface property, different size with another one. So ideally they should be of similar physical property. So we are blending. Blending means mixing together to make a homogeneous phase, homogeneous composition. They will still be powder only. So once we are having the blending, next part will be for granulation. I will be talking about what is the purpose for granulation on this domain. Once the granulation is over, then we'll have compression. So granules we are actually compressing. We are not compressing powder. Of course, example is there. Only we are compressing powder. That example will also be coming into picture. And once compression is made, we are getting the tablets, solid dosage form, which can have some further coating. Different kind of coatings are there. We'll talk about them individually. And then packaging. Packaging is the individual components. I mean to say individual tablets we are putting in a strip. What should be the packaging material? What should be the package material quality or packaging approach? Those things we'll be discussing when we are talking about solid dosage form. Now, if I say about granulation process, what is the process itself? It can be defined as the process where small particle adheres together by forming bond between them, resulting in a formation of large aggregates that is called granules. Small fine particles which are even less than 0.01 millimeter, right? Some 10 micrometer may be there, particle size of those powder, fine powder. These powders of different compounds are brought together, so they will make a bonding between them and they will form a larger aggregates, comparatively large size, and these are called granules. And granules preparation is why you should have actually for granules when we already have powder. This question is very important because we are going in a reverse direction, right? Powder is very fine. Everyone will be happy to have powder. Very easily we can measure some amount. Then what is the need for granulation? The primary need is we can have a powder segregation. Powder segregation is very important problem because powder density is all different, their dimension is all different. So if I'm going to make those things filling in a tablet compression modules, there will be differences. Some small particles will try to be at the bottom, larger particles maybe at the top because they are bigger one. So they will not coming into the die properly. So segregation of the things will be there. Density will be different. Every tablets might have a different density. These problems can be avoided if we stop using powder. But if we are using granules, they will be more free flowing, more easily they can flow. They can easily compacted and they have some pore space. Okay, if there is having some pore space, this pore space can be filled with some fine powder. So there will be complete bonding is possible, right? So that's why we need to have these kinds of granulation is important. It has higher flowability, we can have better flow. So better filling will be there in the die and volumetric doses can be properly managed. Granules have higher porosity than powder, of course, because granules will have some pore in because interparticular space is having air, right? So essentially more than one particle coming in close contact, adhering, but not completely they are combining the entire surface. There will be some pore on the surface. Those surface pore will actually improve the compressibility of the powder. Powder can be easily compressed. Okay, this is one easy point why we should use granulation. Please keep in mind those aspects, very important reason. The granulation of toxic material will reduce the hazard generation. Yes, many times you will be also not only dealing with pharmaceutical compound, some pharmaceutical compound may be toxic even for the healthy individual. Of course, for the person we are going to administer the dose, that is different. So these aspects we should actually, just a second please. No issue. So these aspects we need to take care. If I am making granules, there will be very less chance of aerosol formation, right? It is floating in the air. It is so fine dust. So dusting is less. They are not coming into environment. It will be good for the worker who are dealing in this API formulation division. They will be more easy. Materials which are slightly hygroscopic may adhere and form cake if stored as a powder. That you might have seen. If I am having very fine powder and it is little bit hygroscopic, they can absorb water. They will form big clump. Okay, they'll form cake kind of things if I'm keeping as a powder form. But if I'm preparing in a granule form and if I am storing them, there is very less likely they will stick together, or maybe we can increase the shelf life of those compounds. So these aspects are really very important consideration when you are looking for preparation of granules. There are many methods. First one is the direct compression method. Direct compression method is means we are not doing anything. Essentially, we are putting all the powder and putting in the punch. Not a very good idea for them anyway. Dry granulation method, it is actually granulation method where we are preparing the granules through mixing different ingredients with a binder, but we are not putting any water. So it is water free. C is wet granulation. That means it contains water or aqueous, not only always water. Some aqueous solvent may be there. Liquid is there involved. And the last one is granulation by crystallization. This is also done because many times the crystal has more surface, I mean to say, the increased surface area from generation of crystal from any supersaturated liquid will make a crystal, if I am talking about, they will have some fixed dimension, the edge. So if I am having those particles can actually grow, crystal can grow, and they will have a definitely porous structure. So this kind of crystallization will also improve the porosity and surface texture of the material you are going to use for your tablet preparation. We will be specifically talking about the dry granulation and wet granulation method in this class. There are different variants are also there. I will talk about them. But primarily dry granulation and wet granulation can be the important one. Direct compression is dry process where there is powdered material is compressed directly into tablet. Difference is there. Direct compression is not at all a granulation. Please keep in mind. Just powder we are compressing. That is direct compression. Other variant is granulation method. Granulation will have dry and wet. Some chewable tablets we can also have the direct compression procedure. What is the direct compression here? You see, we are having drug and other ingredients. We are grinding, making it small definitely. Then we are blending, mixing together. We are going into tablet press, preparation of tablet. Straightforward. There is no granulation kind of things are not there. Grinding means size reduction, making a smaller size. That is there, but there is no way we are preparing any granule here. So grinding is drug is added to the granulator and grinded small powder. Blending, suitable adjuvants can be used, which are blender and mixed thoroughly, and then we are going into tablet press. Now, when I am talking about dry granulation means we are producing granule, but no water. That means the whole mixture means our pharmaceutically active compound plus additional additives like binder or diluents, all those things we are putting together, and we are first making a compression. Then we will get some friable kind of tablets which will break down again, but we will not break down them again back to powder, right? So first step is we are having powder, we are compressing to make some temporary tablets, which we will then break it out. So when I am breaking a tablet, we will not make it fine powder, right? We will make some big size granules. Those granules will be fed into second round of compression. Are you getting the point? So we are making a tablet, breaking it down, again compressing. So many times people will also say it is a double compression, you see, because one time preparing tablet or tablet kind of things, then we are breaking, chipping it out and forming. So this process involves formation of tablet by first converting the tablet formulation into slag and compact masses. These formed masses are screened for uniform size fine granules, and this technique is useful for drugs which are moisture sensitive or which can degrade in high temperature, or we are putting in a larger dose. Okay, you got the point? So this can be made up of, they also have some subdivision dry granulation. One is slugging, slug formation, and roller compaction method. Slug formation is like a duff formation, we'll see. Now you see what is the procedure involved in the schematic diagram. First is grinding. We are making all the ingredients powder. If you require, you break them out into small particles. Then blending, dry blending. You are not putting any water. All ingredients of the tablet formulation, including diluent, binder, everything is there. We are making it blending. This blending is powder blending, right? It is completely powder. Then we are compressing, roller compression. You see, we are passing this thing into two roller, and these two rollers are actually rotating in opposite direction. Okay, so if they are rotating in opposite direction, it will come like a sheet, compressed sheet kind of things will come. Then those sheets are crushed, broken down, not into powder. A little bit moderate particle size will be there. Then we are screening. Screening means we should not use any very small fine particle. We should have some target. Okay, these kinds of granules, this size of granules we will permit. So we have a screening step. Then we will blending again those big size granules, comparatively big size, mixing, and then we are putting into tablet press and we are preparing tablets. So this is actually made up of two different steps. That is called dry granulation. This step is dry. That is the only part. There is no aqueous phase is involved. Of course, we can have some binding agents into that. That we will always do. So once we will have the binding agents present in the reaction mixture and we are doing this work, it is always convenient for preparation. It is more easily useful when we are going to have compounds which is water sensitive, which can hydrolyze, which can degrade. Same steps, I already told you the steps, so I think we can move through. Drug is added to the granulator and grinded. First we are making fine powder things. Then we are putting adjuvant, as I told you, diluent and other excipients. Okay, in the blender we are mixing. After mixing, the powder mixture is slugged or compressed into large flat pellets 1 inch diameter. On large scale, roller compactor is preferred, as I shown you, the 2 roller compactor. And then we are crushing down by hand or milling form of the granules. So you're crushing again, and finally we'll be screening, because we need to know what size you are going to take. So once we screen out the size, then we will blend again. We'll put some lubricating agents through using this blender, going to tablet press, die and punches, tablet is prepared. This kind of things is also used for dry granulation method in different formulations. Like you see, formulation of acetyl salicylic acids tablet, vitamin B complex. These are all used for dry granulation method. Aspirin, acetyl salicylic acid means aspirin. So these formulations are actually going for dry granulation. But then dry granulation, what is the problem in dry granulation? The first problem we can be that we really do not have much moisture content. Moisture content is less, means binding force may not be sufficient. So in many times our formulation may need some moisture, so that it can be readily absorbed and more space filling can be done. Compactness can be increased. So we can have this wet granulation method also. It is moist granulation is the most conventional, versatile, widely used technique for manufacturing of compressed tablet. It imparts all the physical properties to the granules. Whatever you need, they can have. How they do that? So we'll be talking about the wet granulation method also. Most of the formulation will have this. Now you see, we are having blending. Okay, we are having CR mixer here. We are having wet screening. Wet screening, I mean to say, we are actually putting moisture level is there. Blending process itself has some moisture. Wet screening is there with those granules which has not dried till now. Okay, wet screening means the blending material which has been processed into small particles, granules. We are first making a wet screen before drying. Then we are drying those things. So putting water, making them little granular, then drying also. Then we will breaking its dry screening process will be there. Once the dry is over, then we will again blend, make powder tablets, and is over. So wet granulation steps will have a inclusion of water or hydrophilic solvent, not necessarily always water. We can have different kinds of alcohols. Okay, polymeric alcohol can be there. We can have some glycol, polyethylene glycol. These things are all water soluble. They can also add up, increasing the strength of the granules we are preparing in the wet granulation process. So principle is similarly, you see, we can have granulator, blending and mixing. We are mixing, CR mixing, granulating liquids. You see, for example, alcohols are added to form some damp mass of the powdered material which resemble agglomerates, which looks like some big flocks. So these things are first prepared. Then we are screening. You see, mass is screened to form pellets and granules. So what particles you will finally allow, that we have to do that in this step. Then we will go for drying. Drying is remove the excess liquid. The drying is easy because many times we can use some alcoholic material which is volatile. If we are putting aqueous based solvent, it may take a little more time. So we'll make the drying of those granules irregular shape. Then we are making dye screening. So that means once the drying is over, then we will also screen out. Why we are making screening? Because even if we are making granules, if the granules are of very different size, then the purpose of granulation is gone. So screening is always there to make sure we are making or we are using uniform size granules for tablet preparation. Blending means we are putting again lubricating agent so that it will flow property will be improved. Then we are going into tablet press and we will be preparing tablets from those granules whatever just now been prepared. Granulation by crystallization is very effective, but we do not really use it in for industrial purpose for API formulation. That can still be used, at least for theoretical point of view. Okay, so I hope you understood the basics. Now we will have some discussion on I hope you understood the logics. We'll have some discussion on how the industrial scale and the production process is involved, and some diagram probably I will try to put you in the context. We'll also be referring one research paper. I have already, I'll be highlighting you very soon. And you may please go through the basic principle of these granulation techniques. Is it clear to you whatever we discussed till now, this granulation PPT? Students, do you understand that? No response, right? I'll show you the textbook portion particularly. Just a second. Okay, so you see, this is talking about this textbook is particularly pharmaceutics, design and manufacture of medicine, Alton's Pharmaceutics. This is also shared with you, and I just want to give an idea what kind of dosage form design and manufacturing process is involved. So here you can see we are having a chapter called, for example, chapter number 28, which is talking about granules and granulation, and we also have chapter number 30. So both the chapters I will be highlighting, particularly the granulation portion. When I am talking about, my screen is definitely shared. You see introduction to the different powder and granules form. You please go through. Actually, the basic principle we have already discussed, why you are making granulation. Please go through the text. Okay, every important points, whatever we discussed in this class can be useful. You can understand what is the reason. You see, improving the flow property, why we are making it, and improving the compaction of these characteristics of the mixture. It is more easy to compress. What should be the ideal particle size? 0.2 to 4 millimeter. Okay, but sometimes we typically use 0.2 millimeter to 0.5 millimeter. Normally we use the particle. So this is the granules typical size. 0.2 millimeter, you understand, na? 0.2 millimeter is really difficult. You cannot really measure it using your scale. But 4 millimeter, yes, we can measure. 4 millimeter is comparatively bigger size. You can hold in your, you can pick up actually. So that much big granules we can really produce, or normally produced when we are going for granulation process. And here you see, this is the schematics. Why this diagram may be interesting for any one of you. What is the purpose? So you see, we are having different ingredients. One small powder, smaller size, someone is bigger size, someone may be heavier. Black is small but heavier maybe. This is big particles but maybe lighter. And when I am making this powder and simply going for tablet preparation, you see, they will fall in a separate layer. They will not be homogeneous. Black will be separate, and the tile color will be separate, big particle will be in the top. I told you, na, that problem can be there if you are making this kind of mixture. Granulation will do the things more easy, and you see, there will be somehow homogeneous. Of course, all of them are not same. You see, somewhere I am having two particle, and this another one is there. Somewhere you will say two different particles of the medium size is coming. So you do not say that all of them are uniform. Definitely not. But there will be a different size also. You see, someone will be big, someone will be small. Then sieving step, as I told you, why sieving is important, so that we can at least have nearly similar particle size. So out of this, we are only allowing these kind of steps. You see, two big size particle, one small and small. Why I am showing this is just schematic only. The reason is that we can actually have homogeneous composition. Like here, 2:1:1. Two of this, one of this, another of this. So this process can only be ensured if we are going to include sieving. So purpose of sieving is definitely you understand what is the reason we are going to have. What could be the other reason? I already talked. It can be some toxic material, right? So you must be more precaution when I'm going to have no powder will be formed, no aerosol will not be formed. You'll be more safe. And slightly hygroscopic may adhere and form cake. This property I already talked about. In powdered and granulated doses form, we already speaking about solid preparation, which is more chemically stable than liquid. So shelf life can be improved. So we'll look for this. Okay. So you can understand what is the powder and granules for oral administration. Directly, some granules can also be used, but we are simply we are not really considering about that. So sometimes directly granules can also be used as a formulation. You may study, but we will skip that. We are really not on the same domain. Okay, these are the different formulation. If you want to study, okay, this can be directly used for formulation. So powder and injection, granule used for some medicated manufacturing tablets, and we can have some pharmaceutical taste if I'm going to use. Now they're talking about dry granulation technique. The doses of granulation, primary powder particles are aggregated into high pressure, and that is called slug. I will just highlight it so that you can always keep a track on this. Okay, so dry granulation method we are talking, and then you are talking about involving wet granulation or wet massing. Now granulation process is also important because this will decide the particle bonding mechanism, how they are binding. This is also very important. The binding mechanism for any granules can be of three different types, I will say. First one is through, okay, I'll go to my presentation rather, then I'll speak about this aspect. So we are talking about granules, fine. But do you think any compound or any powder mixtures can be used for granulation? No, there is some certain reason behind that. First of all, in most of the time we are talking about some powders. Powders means some active ingredients. And how are they organized? First of all, many of the time we are using organic compound, right? Our pharmaceutical doses form, many of them are actually organics. And if it is organic compound, we are likely to have different functional group. COOH, some acidic group can be there, amino group can be there, carbonyl group can be there, depending on the property. If it is, for example, starch-based compound, then we definitely have some carbonyl will be there. We can have CHO group can be there. Okay, so aldehyde group, amino group, carboxylic group, hydroxylic group. These are the most predominantly widely recognized functional group on the particle of your active ingredients. When I am talking about the binder, some molecule, for example, this is your API, active pharmaceutical compound, and this is, for example, your binder. Many times you will find that they are forming actually hydrogen bond. We can have, for example, OHH. This is one molecule, this is another molecule. So this bond, of course, non-covalent bond, hydrogen bond. So in between them, some hydrogen bond formation can be there. They can have some ionic bond formation. Why? How essentially? So for example, this is some amino functional groups are there. And depending on what is the surrounding environment, it may be NH2, can be NH3 plus also. And for example, here I am having OH minus group. So we can have two groups which are actually, one is positively charged, another negatively charged. So hydrogen bond formation can be there, ionic interaction can be there. These forces are actually you cannot ignore, because when I am assuming that more than one particles are coming and adhering, that means there must be some bond. Okay, what is the bond working on? So these can be the most of the important bond is hydrogen bond formation, ionic interaction can be there. Covalent bond formation is rare. We do not really have covalent bond formation. We do not want to react them, right? We are not promoting any reaction scheme when we are talking about this kind of formulation. So please be clear how the different bond formations can actually improve or important when we are talking about this between them. When I'm talking about the liquid or maybe wet grinding process, wet granulation process, you can see there can be some liquid breeze. That means a pool of water can be there, or solid breeze can be there. So this liquid and solid breeze can actually hold them together, and it can look like a suspension. You can dry it up and you can use it. So please go through the different reason what could be the process over there. Mechanism of granule formation that we already talked here. You see, we can have coalescence, binding, growth, and breakage. So this is the basic mechanism. You need not really go through them in details, but you can just go through what are the process they are using, how they are making procedure, wet granulation they are talking. So please go through this chapter number, I mean to say 28. Okay, please go through the chapter 28 for further payment. Is still going on. Let it go for some time. You have to write something. Okay, let it be there. So until or unless we are having these details, I will always suggest you to please go through this preparation of granulation process. Is it clear? Okay, fine. That is already over. So once we know the granulation things, the mechanism involved, we will be talking about some advanced granulation process. I will refer you one rather paper here. Here. This is a 2015 publications which is talking about granulation technique and technologies, talking about recent progresses on granulation, published in Bioimpact Journal in 2015. So still it is 6-7 years old work, but I'll strongly suggest you go through it. The reason is that there is a very good number of figures for demonstrating the process. Just I'll be going through, and you see this is the weight they are showing. I have taken this diagram from this paper itself. What is the advantage? Why? Which one is more preferred one? Of course, the moist granulation is preferred. They can have some different variant also. Someone is known as steam granulation, someone is moist activated dry granulation, moist granulation, thermal adhesion granulation, melt granulation, freeze granulation, many. But basically they're all involving some amount of moisture or water. They are mostly done, mostly preferred one. And the dry granulation is pneumatic dry granulation. Pneumatic means through use of application of pressure, that is called pneumatic. So pneumatic dry granulation will actually do the dry granulation process. Only one approach is considered. I think I need not speak on that. Facilitate the metering of volume, and this is the purpose already I talked. This is the particle size we will be normally talking about, and this is the diagram possibly taken from this article itself, how we are going to do. So we are going to have this two schematic for the presentation. We are making a blend. Once the blending is over, we can go into dry or wet granulation. So when I am going for dry granulation, so dry granulation uses liquid for granulation, water or solvent without any binder. So that is also differences. Use mechanical force for granulation, no liquid. I think they have shown the diagram wrongly, people. This is actually dry and this is actually wet. Okay, this arrow they have made wrong, not my photograph here. So they are putting addition of lubricating agents. They will be putting everywhere, mixing, and then they are making a tablet. So directly using, if I am directly using this, that is called direct compression. If you are going through this granulation process, it is called dry or wet granulation technique. So you can see the dry granulation more schematic here. First we are going into roller compaction. Roller compaction will make some flakes like a small sheets. You break it down, make granules. Okay, and once you are making granules, this is only for roller compaction method, and this is one is slugging. Slugging means you are actually putting some compressed machine like a tablet, break it down, mill it. It is like one kind of tablet itself. Break it down, make the granule. These granules will be further used for tablet preparation. This is dry pneumatic one. So pneumatic forces will be applied on this roller compactor here. They will make pressure here. Pneumatic system is for pressurizing the components, and maybe they will be separating out. The granules are still there. You see, granule means more than 2-3 compounds are attached molecules. Then is also a cyclone separator. Cyclone separator is actually a column of air moving up. So what will happen? It will actually take out the very fine particles. So very fine particles will not go into your tableting machine, and you can separate them and you can process further. But if there is very fine particle coming into your preparation, that can be difficult to maintain the homogeneity of the preparation. That is always taken care when we are going for granulation process. This is a pneumatic dry granulation process, widely used for industry. Okay, so please have an idea. I'm skipping this and I will just show you the paper which I am actually suggesting. I have taken these things. You can quickly go through. Very simply, they are talking about what is the advantage, what is the disadvantage, the summary for easy understanding. I am no way forcing you to go through the entire details. You can easily understand, and so I have not written here. Dry granulation, mild compaction, what is the advantage, porosity. Okay, we can have fast disintegration time, release time modification can be done. So these can be the characteristics. What is the merits? We can have some drag loading can be increased, thermolabile material and moisture sensitive product. We are not heating up them, right? It is more easy. Product stability is increased. Cost and waste can actually decrease. It is more easy. We can have resiled granule quality can be a limitation. Segregation potential can be there, and friability. Friability means tablets are very easily breakable. So that can be one problem. Equipment is, you already know, roller equipment. Okay, so we can always have pneumatic dry. Steam granulation process is actually same wet granulation, but steam is the granulating liquid. So we are not really putting water. We are actually making the steam on the surface of the particles. So steam as surface of the particle means we are not putting any extra water, only the surface is moist. So if the moist surface is there and we are bringing two hydrophilic compound surface together, they will form a bond. Okay, and this bonding can actually increase the strength. You can please go through the steam process. And these are the diagram. There will be lots of diagram for dry granulation, and this is wet granulation. You see, I'm having a granulator, dry powder I am putting, mixing, then we are putting some water or solvent, then again we are mixing, we are breaking. Actually, we will be breaking it further. So dry granule masses will be there, will dry, sizing, and will be becoming dry granule. And dry granule will be used for tablet preparation. Same way here, reverse wet granulation scheme is given. You see, we are having some granulator. So we are having binder, water, solvent, all those things are there. We are mixing dry powder, we are putting together, again mixing. Now we are separating by wet granulation mass, then we are drying. And then we are having dry granulation mass, we are sizing and drying. So these principles are actually going to give you how we can have the different procedure for segregation. I'm not going further details here because there will be similarly same procedure. Only thing is that we can add some ingredients in step 1, step 2, or step 3. That is the only difference between the process or procedures. I think I can close it here, this class. Further details we will be discussing in our next class when we will be talking about the formulation of the granulation process, what component, what ratio possibly we will be using in pharmaceutical industry, what should be the concern when we are going for granulation technique, or major limitation when you are going to adapt any of them. Okay, so if you have any questions and queries, you may please ask me. Otherwise, we'll stop it at this point. Any questions from anyone?
No, sir.